Hello. So our topic is OSPF. Firstly, I will give you a brief description and everything of about OSPF. So what is OSPF and full form of OSPF? Firstly, it is Open Shortest Path first. It is Open Standard Routing Protocol. It is Link State Routing Protocol, which is IGP protocol, Interior Gateway Protocol. Because of Interior Gateway Protocol, we will use metric as a cost and the ATE value is 110. So here we will use metric is cost and the AD value will be 110. IP protocol number here we will use is 89 and the multicast address, two type of multicast address here will be used. First is for all router, we will use for all router we use 224.0.0.5 and for DER router we will use dot 6, that is 224.0.0.6, and it is layer 3 protocol. The by default the maximum path will be 4 and we will increase up to maximum 16. Okay, so by default the path will be 4, but we will increase up to 16, maximum 16. And by default the auto summary is disabled because of congestion and to avoid the congestion mainly, and it use SPF algorithm for best path selection. So here is we see that metric will use as cost. So how we manipulate and calculate cost? Here we use a formula for it. So cost is equals to reference bandwidth. Reference bandwidth is by default 100. By default 100 divided by link bandwidth, which is in Mbps. For example, for Ethernet, fast Ethernet, we will manipulate. So it is 100 by 100. The cost will be 1. For Ethernet, it is 100 by 10. So our cost will be 10. For serial link, it is 100 by 1.54. The cost will be 64. This is how we will manipulate our cost. So here is the type of table which we will use in OSPF. So here is 3 type of table. First is neighbor table. Which contain every information of neighbor. Second one is database table, which contain LSA, that is link state, advertisement, and sequence number. And third one is routing table. Routing table must be contain full information of topology. So here is three type of table we will use in OSPF. Now, five type of message over here. First is hello. Second one is DBT, database description. Third is link state request. Fourth is LSU, link state update. Fifth is LSA, link state acknowledgement. So here is how many type of message? Five type of message here we will use. So type of messages. Type of messages. First is type 1, hello message. Hello message. It will use to discover neighbor. First is it help to discover neighbor, and it help to keep alive message, and it is periodically give message there. It is periodically give their message in every 10 seconds or 30 seconds, and the dead timer of it is 40 and or 120, and the multicast address it will use as 224.0.0.5, and the unicast when we set statically. That means it multicast is by defaultly set, but for unicast we will set as statically. So it is the use of hello. Hello is very important, and you can understand why hello is important. DBD, database description. We will study further in brief. Database description. Type 2. Type 3 is LSR, link state request. Type 4 will be LSU, link state update. Type 5 will be LSA, link state acknowledgement. So this is the type of messages. Content. What type? What will be the OSPF will be content in this. So the content of OSPF will be here is OSPF. Firstly, OSPF version. Second, type. Third is packet length. Fourth is router ID. In router ID, we will elect its router ID to represent itself in the OSPF domain. It is 32-bit decimal number. The format is IPv4. And how to elect the router ID? Firstly, statically router ID, and dynamically we will check highest IP address of loopback, and second one will be if we are not able to conclude via loopback, then we will go for the highest IP address of interface, physical interface. This is the type of this is the way to calculate to elect the router ID. And then we will check area ID, then checksum, the authentication type, authentication database, the subnet mask, hello timer, dead timer, and priority. In a single area, minimum is 30 and maximum will be 50. So DR router ID and BDR router ID, neighbor router ID. Three type of ID we will contain. And then what is the neighborship parameter in it? So what is the neighborship parameter? In OSPF, first is router ID must not match. Second is router area ID must will be match. And the authentication type and authentication data must match. Subnet mask must match. Hello and that timer will be match. MTU size will be match. And stuff flag will match. OSPF net type should be match. And the neighborship states will be down, init, attempt, two-way, start, exchange, and loading, and full. So, what is neighborship? We will briefly understand what is the content of this OSPF and how to manipulate and elect a router ID, and what is the packet length and what is type and why we will use these things in OSPF, what is the main purpose of this, and the parameter of neighborship is why it is important. So we firstly note it out. Neighborship parameter. It is first is router ID will be match, must match. Second was area ID must match. Third is authentication. Sorry. Router ID must not match. Okay. And area ID must match. Okay. And third was is authentication must match. Authentication type must match, and subnet mask, subnet mask must match. Area will be match. And I already noted out the area ID match. Now subnet mask must match, and MTU must match, and stub flag will be match. Stub flag match, and OSPF net type should match. Should match. Really should match. Now, neighborship states. First is down, init, attempt, two-way, xstart, exchange, loading, and full. Now we will see small practical over on GNS. First, we will create OSPF. We will use 7200 router. We will use fast Ethernet cable. Now it connect. We will start. So take their console. We will go in configuration mode, global mode. Now we will go in interface F0 by 0. We will assign IP address 112.1.1.1, 255.255.255.0. No share. Same. We will go in R2 in configuration. Now interface F0 by 0. IP address will be 12.1.2, 255.255.255.0. No share. Now we will capture. Start capturing. Start the two-way to assign OSPF. Firstly, see router OSPF 100. 100 is our process ID. Okay, it will be same or different. Network 12.1.1.0. Then destination will be any link advertisement. It is used for link advertisement. A0. So we will say what the only reply. No hello will be exchanged over here. So now we will do link interface will We will, for hello packet, we will advertise interface. So we will go in interface F0 by 0 and IP OSPF 100 A0. Okay. Same way we will go in this interface F0 by 0 IP OSPF 100 area will be 0. We will study about area, why we use area 0 first, why we use area 1, what is the role of area over here. Now you can see this hello packet will be start. Hello packet will be exchanged over here. Reply also. You can see DB description packet also. You can see here Ethernet 2 header will be used. IP version 4. Source will be 12.2 and the multicast address will be used over here. So here I already write it out. You can see DBD hello see description request update acknowledgement all packets are exchanged over there. This is how our OSPF work and this is the type of message here and this is the their header. You can open their header individually and you can see what type of things are going and what is that. Here you can see 224.0.06 that is our DER. Not multicast all for all router, it is for DER router multicast. So here it is DER and the source is dot one. In further class, we will understand what is DR-BDR election and how it will elect over there because we will use fast Ethernet. That's why in serial link, no DR router is available. Only multicast address will assign over there. So we will stop the packet capturing. This is our small practical over there. Now you can understand everything. So thank